Hey guys, the purpose of this video tonight is to show you how to take and to draw an orbital diagram for an element, which I've already prepared for you on the screen, and also to turn that into a Lewis equation. And we'll do those two things at once, and then I'll show you how we can combine the Lewis equations together in order to come up with the formula for a substance that is going to be created. So I've got it prepared up here already for us to draw the orbital diagram for potassium. And so what we'll do is we'll go ahead and we'll draw that orbital diagram for potassium. The first thing we need to understand about potassium is the number of electrons it has. So the number of electrons that potassium contains are 19. So there's 19 electrons. We know that by looking at the periodic table, and if potassium is neutral, we know that there are going to be 19 electrons. So if we draw the electron configuration for that, we come up with 1s2, 2s2, 2p6. At this point, we've got 10 electrons. 3s2, 3p6, which includes 18 electrons, and then finally 4s1. When we look at this, we can count the total number of electrons as 19, and now it's just a matter of placing them from low energy to high energy. So we need to remember our electron configuration rules, and we're going to start with the lowest energy and work our way up to the highest energy. We need to place one electron in each orbital at a time, and then after we have filled up that particular orbital at that sublevel, then we can move up to the next one, and so on and so forth. So we're going to start by putting an up arrow and a down arrow. That represents the first two electrons, represented by 1s2. Then we'll go up, down for 2s2, and we're going to go up, up, and up, okay? Because remember, we want to make sure that we have one electron in each orbital at a time. Down, down, and down. So therefore, we've got 10 electrons placed. We need to fill 19, so we're going to keep going. We're going to go up, down is 12, up, 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 down, down, down. So now we've placed 18 of those electrons out of the 19. So the last one is going to go in the 4s1, which is going to go up, just like that. So that's the orbital diagram for potassium. Now when we take this orbital diagram for potassium, we can go ahead and we can understand that in order to form an ion, in order to draw the Lewis equation for something which is forming an ion, what we want to do is we want to try to come up with a completely filled or a completely empty highest energy level, known as the valence energy level. So we can see that the highest energy level here is the fourth energy level, okay? And so we want to either fill that up or empty it out. So the way we can fill it up is by adding 7 electrons. If we add 7 electrons, there would be one more that went in the 4s and the 6 that go in the 4p, in which case that would fill it up. But the problem is that to add 7 electrons would require a lot of energy. So it's easier if we remove a single electron. So what we'll do is we'll take that single electron, that electron goes away. Now what we need to understand is that we started out with a potassium atom that had one dot on it for the Lewis dot structure. Okay, so it was one dot. Okay, and what it did was it lost one electron, okay, to become potassium with a 1+ charge. How do we know it has a 1+ charge? Well, when we look at any potassium, what we know is that all potassium atoms are going to contain 19 protons, because that's what defines this as being potassium. Okay, so there are 19 protons that make that up. We've removed an electron, so because we removed an electron, we're left with 18 electrons at this time, and then when we add 19 positives with 18 negatives, what we end up with is 1 positive. So therefore, that 1 positive charge that we were talking about goes right here, and we correlate that as such. So that's where the 1+ charge comes from. So now we have to ask ourselves, okay, that's all fine and well. How do we go about figuring out how potassium is going to combine with something else? So let's go ahead and take a look at another example. And so I did potassium first, but now let's go ahead and look at another example. Let's combine potassium with oxygen, for instance. Okay. So the question is, what does the Lewis diagram look like when we combine potassium with oxygen? Well, the first thing we need to do is to start over again. Okay. And so what we're going to do is we're going to go ahead and combine potassium with oxygen. I'll go ahead and rewrite that 2s right there, so we're all looking at the same thing. Okay. So this is 2s. And if we're going to go ahead and combine potassium with oxygen, I'll make sure I use a slightly different color. Let's go ahead and use purple. Okay, we're going to take a look at oxygen. And if we look at oxygen, we know that oxygen as a neutral atom is going to have 8 electrons if it's a neutral atom. So the electron configuration would be 1s2, 2s2, 2p4. So now we can go ahead and place those electrons. Up, down is 2, up, down is 4, up, 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 down. So there's our 8. What we can see here and what we can see is going on is that we've got empty spaces here where we could place electrons if we wanted to. There's a spot there and there's a spot there. Okay. Now, if we remember correctly from our potassium example, that was willing to give up the 1 electron right there. So potassium is willing to give up 1 electron. Oxygen is willing to take 2 electrons. So I guess the question would be, what does the Lewis equation for oxygen look like? Well, we've got oxygen, okay, and as oxygen, it's going to have 6 valence electrons. We know it's got 6 valence electrons because when we look at the highest energy level, we can count them 1, 2, 3, 4, 5, 6. Okay. We know that oxygen wants to gain 2 electrons in order to have a full octet equal to 8, because if it gains those 2, it'll have an octet of electrons. So it's going to be oxygen with 1, 2, 3, 4, 5, 6, 7, 8 electrons. And now, because we've added 2 electrons, it's going to have a 2 minus charge. So the question is, how do we go ahead and we add these two things together? Well, it's pretty simple, okay? We know that oxygen wants to obtain electrons. It wants to obtain 2 electrons. Potassium is willing to give 1 up. So what we're going to say is all right, in order to make the 2 electrons match, oxygen wants 2, potassium is willing to give up 2, we need to double the number of electrons. Well, in order to double the number of electrons that potassium gives up, we have to double the number of potassiums, and as a result, double the number of potassium ions. So now it's just a matter of adding these lines up. What we end up with now is 2 potassiums with a dot. Undo that. 2 potassiums with a dot plus an oxygen with 6 dots, 1, 2, 3, 4, 5, 6, plus 2 electrons here. Now what I've done is I've taken everything that's been on this side of the equation, okay, potassium, okay, the oxygen, and the electrons, because they were all on the left side of the equation, okay. These elements right here are all on the left side of the equation, okay. And so we've taken the 2 potassiums, the oxygen, and the 2 electrons, okay. What we're going to continue to do is we're going to go ahead and add them up. I don't know if you just heard that. One of my kids just fell upstairs. It made me chuckle a little bit. I don't hear any crying, so I guess they must be okay. So we got 2 potassiums, an oxygen, 2 electrons, and it's going to give us the 2 electrons, okay, plus 2 potassium ions, 2 potassiums that have a 1 plus charge. So there's your 2 electrons there. There's your 2 potassiums there. And then a single, let's see if I can fit this in, I'm going to try to, a single oxygen atom with 8 valence electrons, 1, 2, 3, 4, 5, 6, 7, 8, 8, come on, put it in there, okay, with a 2 minus charge. Okay, so barely snuck it. Last step. We can see there are 2 electrons on either side of this particular thing. So we can cancel those out because it's showing up on both sides. So then it's just a matter of reducing. We end up with 2 potassiums with a dot plus a single oxygen with 1, 2, 3, 4, 5, 6 dots. It's going to yield the 2 potassiums up here. Now what I want you to remember is when we put our final answer together, okay, we're going to actually write that as K2. Okay, so rather than 2Ks, we'll write it as brackets K plus 2. No, did that again. Okay, K plus 2. Okay, and then the oxygen with the 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. Close that up with a 2 minus charge. So what this tells us is 2 potassium atoms will react with 1 oxygen atom to form a substance made of potassium and oxygen. And the reason that this works is because each potassium atom is going to give up one of its electrons to an oxygen to make it happen.